Hello, I'm Thomas Marshall Hill with the Louisiana Department of Transportation and Development. I'm here to talk to you about the mitigation of roadway cracking caused by soil desiccation from trees. Uh, some clay soils shrink and crack when they dry and they swell when they're wet. As you can see from this slide, uh, how the soil cracks, especially if it's a high PI material, when it dries. The issue with that is when you have a clay material under the roadway and it dries, that cracking and sometimes swelling when water's added causes damage to the roadway. What it does is causes cracks in the roadway, which during the wet season allows additional moisture to get to the subbase, weaken it, and cause these premature failures. Now, most of the time, the areas under roadways and the subbase stays fairly moist. The road protects the subbase from drying out. It protects it from that drying potential of the sun. Uh, what happens in really dry seasons, trees are searching for water to survive. Uh, so during really dry seasons, roots propagate under the roadway to extract this moisture for the tree to stay alive. And what that does is dries out the subbase up under roadways. You can see from this picture, this is taken on US 165 in Madison Parish. You have cracks along the edge of the roadway here on the side where trees are. On the other side, there are no cracks. You can see it better in the next picture, next slide. These pictures were taken almost adjacent from each other. You can see on this side how the shoulder is failing with the trees along it. And then just across the roadway, you see this shoulder with no damage at all. So what are the research objectives? What are we trying to do? What we want to do is provide some research correlating some soil characteristics to tree type size and distance the trees are from the roadway. What this will do is offer a tool to the local Department of Transportation officials and local public works agencies who are all trying to battle this same topic. And it'll give them a tool to help them in their decision making. It will also serve as a training resource for new engineers to help them understand the root cause of the damage to the roadway in these areas. How are we going to do this? What are the research plans? What I'm proposing to do is collect data along a 5-mile section of US 65 in Madison Parish. What I will collect is the distance from a roadway to a tree location. And what that'll help me determine, is there an effective area that specific tree species, root systems cause damage to the roadways? We'll also collect the size of the tree and type of the tree. Does the size, age, a specific species of tree cause more drying than other species? Is there more drying potential for a certain species than another species, or the certain size of a species? We'll also get the location of the cracks or damage in the roadway and or shoulder at these locations and correlate that back with the trees and the damage that may be caused. Other thing we'll look at is some soil Atterberg limits. Is the plasticity index an indicator of the damage potential to the roadway? Are there certain higher PI materials that are more receptive to damage than others? All the local DOTD labs currently use Atterberg limits in their decision making on road projects. So they have those capabilities now, so it'll be something that's readily available, a test that they can do now, and some have already done, and just use that data in the decision making on how they build a new roadway or maintain the roadways. We'll also use DOTD's archives for any available soil characteristics. They currently take Atterberg limits when they do an overlay, so some of that data may already be available. And also the pavement typical sections. Is it a composite pavement, meaning asphalt, concrete together? Is it just a concrete? Is it just an asphalt roadway? What are the bases? Is it a stone base, a soil cement base? That type data, and correlate it with the other data we're picking up. All right, you can see this is just some sample data It can be picked up with a simple spreadsheet, a tape measure. You're looking at a station, which is just a location along the roadway, a frame of reference. We'll pick up the distance that there are to trees. You see here the size of the tree, what the species is, roadway typical section, soil PI, liquid limits, which is part of the PI, and is the road cracked or not cracked. Simple measurements, you can do it with a tape measure. One person can do it. If you have to, you're measuring from maybe this edge line right here. You can take something, hold your tape, measure here, get the species of tree, get that information. Two people can do it easily. Just a safety vest, maybe some signs, safety signs as you approach the work area, but that's really all that's needed. Preliminary results. All right. Did a small sample of this data just to look at it, and from the small sampling that I did, if once the trees got beyond 50 foot from the roadway, there was no damage. So just preliminary, looks like there's going to be a distance there where the tree, if it's far enough away, will not cause any damage to the roadway, which would be a good indicator if you're building a new roadway and you're buying right away in a certain area where the soil characteristics are a certain way. Maybe you can specify a minimum right-of-way distance to keep all vegetation away. The other thing I noticed was there was a certain species of tree that was predominant when you had the roadway cracking, and the trees were somewhere between 20 and 50 feet from the edge of the pavement. So from those two things, it looks like there's going to be a clear relationship between tree type, damage, and location. We think that from the final study, we should be able to get that relationship. All right, impact. A correlation between soil characteristics, tree type, and distance from roadway will help transportation officials in the decision-making process. All right, can you remove just select trees instead of all the trees? Removing all the trees is very expensive. If you determine that there is a certain species of tree that's causing a problem at a certain distance from the roadway, you can just remove those trees, which would also permit non-destructive trees to remain in the right-of-way, which will improve aesthetics. It also keeps you from having to mow. If you clear the whole right-of-way, you have to mow it to maintain it. If you can allow certain species to grow there, then that area does not have to be mowed. You could possibly place root barriers at locations where destructive trees cannot be removed. So if you have an area where the right-of-way, adjacent right-of-way, adjacent landowner property gets up close to the roadway, and the trees are on his property, and you can't remove those, then you could selectively place root barriers in those locations where the certain tree species, distance, and soil characteristics match, which would be a huge savings instead of having to put a root barrier system the length of the roadway. It also will help justify spending and acquiring federal monies for clearing projects. Currently, when you do an overlay using federal monies, they're sometimes hesitant in spending those monies in clearing roadways, as they think that clearing trees, because they feel that is a maintenance issue. But when you can show that clearly it's causing damage to the roadway, then those monies may become more available. All right, conclusion. Soil desiccation by trees and the subsequent damage to roadways cost taxpayers millions of dollars. Many DOTD and local public works departments may not be aware of the root cause of the damage or be familiar enough to make an informed decision to mitigate this damage. This research will provide them a much needed tool to help maintain their road system. All right, thank you.